Good morning. This is Jolie and Christopher, and we will be presenting negative binomial regression and how to use it in SPSS. Our agenda for the presentation will be as follows. What is behind the name of this method? When to use this method? How this method is similar or different than OLS? Unique terminology? How to use negative binomial regression in SPSS? Goodness of fit measures? And how common this method is in FT50 journals. What is behind the name? Binomial distribution and negative binomial distribution are two important methods of modeling probability distribution in Bernoulli trials. Recall Bernoulli trials have only two possible outcomes and assume there is only one outcome for each trial. Each trial has the same probability of success, and each trial is independent of each other. Let's start with the definition of a binomial distribution. A binomial distribution is a simple and a commonly used discrete distribution, showing probability outcomes in a fixed number of independent Bernoulli trials. It is usually measured in percentages and defines the percentage of successes or failures in a fixed number of trials. An example of a binomial distribution would be determining the probability of flipping 5 heads out of 10 coin flips, which in this case is 25%. Note that the curve of the binomial distribution is similar to the normal distribution, the key distinguishing feature being that the binomial distribution takes on discrete values versus continuous values for the normal distribution. A negative binomial distribution, also known as an NBD, is a commonly used form of discrete distribution that measures counts versus percentages for binomial distribution of successes or failures in a number of independent Bernoulli trials. To note, counts are defined as discrete, non-negative integers. An example of a negative binomial distribution would be determining the probability of getting the 5th head on the 20th trial. Note the number of trials is given and the cutoff on the graph is 0. There is no tail going into negative. We will now look at regression models of these distributions. How is negative binomial regression different than OLS? OLS is the most widely used form of regression. It is not, however, appropriate in all cases. More specifically, when the dependent variable is discrete rather than continuous, meaning that it takes on a particular value and is countable, or when the independent variable are nonlinear or are overly dispersed, resulting in a low R-squared, indicating that the model has a lower level of fit and ability to predict. Negative binomial regression is closely related to Poisson, which was just presented by Blair and Grayland. An important attribute of the Poisson method is that the data is not overly dispersed. In other words, the mean equals the variance. The Poisson method forces the variance estimate to equal the mean at each point on the regression curve. The problem is that if overdispersion does exist, this can lead to inaccurate conclusions that there is an association of a predictor when there actually is not. This is when negative binomial regression comes in. Negative binomial regression is a generalization of Poisson regression, which loosens the restrictive assumption that the variance is equal to the mean. It assumes the dependent variables have overdispersed variance. In other words, the variance is greater than the mean. Because the negative binomial allows for greater variance, it often provides a more flexibility in fitting the data to the model. So when does the overdispersion occur, requiring a negative binomial method? First, when there are excessive zero counts in the data or the data is skewed. Take, for example, the measure of the number of days absent at a company for a specified time period. Many people will never be absent, zero count, and the results are often skewed to a fewer number of days. On the other hand, there are few employees who will be absent 20 days or perhaps more due to extended illness. As we can see, this results in the mean being different than the variance.
Before we move into looking into how to model negative binomial in SPSS, we need to understand some important unique terminology. The key difference between a Poisson regression and a negative binomial regression is the dispersion parameter. The dispersion parameter adjusts the Poisson for the variance. If the dispersion parameter would be 0, then it is a Poisson. Two important terms for measuring goodness of fit when determining the right model to select. Akake's information criteria, AIC, and Bayesian information criteria, BIC. The most important thing to know is that you select the model with the lowest value for these parameters. How do you know if you need a negative binomial regression instead of a Poisson? Well, after running a Poisson, check for overdispersion. First, under descriptive statistics, check if the mean is different from the variance, or look at the deviance under goodness of fit to determine if the ratio of value to DF is greater than 1. The bigger the value, the more dispersed the data. Running negative binomial regression in SPSS is similar to Poisson, which was reviewed by Blair and Grayland. After entering the data, select Analyze and Generalized Linear Models. Instead of selecting Poisson, select negative binomial with log link. Under the Response tab, enter the dependent variable, and under the Predictors and Model tabs, enter the independent variables. Under Estimation, leave the default settings, and under Statistics, add Include Exponential Parameter Estimates to the default settings. Reading the data. You can determine the positive or negative effect of each predictor based on the beta coefficient and the significance level. Looking at the omnibus test, if there is significance, this indicates improved model fit over null hypothesis, which has no predictors. There are a few measures of goodness of fit. Pearson chi-square should be close to 1. In addition, AIC and BIC are used to compare models against each other. The model with the lowest AIC and BIC score has the best fit. An alternative SPSS method of conducting negative binomial regression is to use custom instead of the negative binomial function. The negative binomial function assumes the dispersion parameter. The parameter that adjusts for variance is 1. Custom allows you to adjust for overvariance and hence can lead to more accurate results when there is high overdispersion. Here is an example that uses a negative binomial versus a custom function. With the negative binomial function, we see the independent variable education is a predictor according to significance levels. Using the custom function, which allows for additional variance, we see that education is not a predictor as significant levels are above 5%. The custom model has better goodness of fit as indicated by a deviance ratio closer to 1 and lower AIC and BIC values. How is negative binomial used in research and practice? Negative binomial is a commonly used discrete distribution in cases where the count data is overdispersed. Common examples include measuring absenteeism in workers or students, quality inspection in manufacturing, and sometimes in purchase behavior for marketing groups. This wraps up our presentation on negative binomial regression. Thank you for your time, and we hope this is helpful.